Hey everyone, welcome back, and today let's solve Leetcode problem 56 titled Merge Intervals. So we're given an array of intervals where intervals that indice I is going to have an array of length 2 that has a starting value and an ending value. We have to merge all overlapping intervals and return an array of the non-overlapping intervals that cover all of the intervals in the input. So note that intervals is being used a lot in this problem description, and so this may be pretty difficult to visualize and understand what it's actually asking. And so let's just go ahead and dive directly into the examples to better visualize how this actually works. So in example 1, we have the input to be intervals of nested arrays that are going to be 1, 3, 2, 6, 8, 10, and 15, 18. And we basically merge intervals 1, 3, and 2, 6 because they would be considered overlapping. And the reason why they'd be considered overlapping is because 2, 6 starts at value 2, which is before 1, 3 ends, which is at value 3. And since this interval starts before this one ends, these are considered overlapping, and we'd have to merge them into one interval of 1, 6, where 1 is basically the minimum starting point of both of these intervals that are overlapping, and 6 is the maximum ending point of both of these intervals that are overlapping again. And 8, 10, and 15, 18 aren't overlapping because, of course, 15, 18 starts only after 8, 10 begins and ends. And so we simply keep them the way they are and simply merge 1, 3, then 2, 6 to return an array of those new merged intervals. And, of course, the non-overlapping intervals are going to stay the same because we don't actually have to merge them if they aren't overlapping. So note that asynchronous operations are not allowed, meaning this 2, 6 cannot be running or cannot be in play while the 1, 3 hasn't completed yet. So this has to be a synchronous problem or operation where we have to finish 1, 3 first and then move on to 2, 6. But in this case, that's not possible, and so we'd have to merge them into one interval to be able to finish one interval at a time before actually completing that and moving on to the next one. So in example 2, we have intervals to be a nested arrays of 1, 4, and 4, 5. And you may be thinking, great, these aren't overlapping because 1, 4 ends, and then right immediately after that, we'd start with 4, 5. But in this case, our starting value for any interval has to be greater than strictly the ending value for any other interval. And this actually doesn't pass our requirement because the starting value for 4, 5 equal to 4 is actually equal to the ending value for 1, 4, which is also equal to 4. And in this case, those are still considered overlapping, and so we'd actually have to merge them to 1, 5, where again, 1 is the minimum value of the starting point for both of these overlapping intervals, and 5 is the maximum ending point for both of these two intervals that are overlapping. So if we had like 1, 4, we couldn't have an array after that or an interval after that that starts with 4 because they would still be considered overlapping because they start and end with the same value. We'd have to start with 5, and after that, of course, we can have whatever we want. We can have 6, we could have 6, we could have 7, we could have 8, we could have 9. Doesn't really matter. We'll just have to start with 5 or anything strictly greater than 4 or whatever value that interval actually ends with. And only then are they considered to be non-overlapping. So with that problem statement out of the way, I will give you guys a few seconds to kind of just go over this problem in your head and think of a valid solution, and then I'll show you guys how I would optimally solve this problem in a bit. Okay, so the very first thing that we want to do to actually accurately store and compute every single potential overlapping interval is we want to actually sort them by the very first starting point of each interval. And so in the Python, the way we do this is we'll say intervals dot sort using the dot sort method, and for our key we'll pass in a lambda function. Okay, lambda, let's just say x, where the sorting key value pair is going to be x at indices 0. And essentially this line just sorts the interval based on their starting value, basically x at indices 0. And sorting helps to bring overlapping intervals next to each other, which is actually very crucial for merging them later. And by sorting, we'll basically ensure that if two intervals overlap, they will be adjacent after sorting, making that merging process a lot easier. And for any of you guys who know runtime complexity well, you know that this would actually be a big O of n log n operation. And so yeah, and you really can't beat that with sorting. And yeah, and lambda is essentially an anonymous function that takes in some parameters that we actually use to sort based on a key pair or key value of our iterable, which in this case is going to be the intervals array. And once we actually sort the intervals array by every single interval's starting value or interval at 0, now we actually have to kind of create our resolution array, which we will ultimately return, which is basically going to be an array that consists of all the different non-overlapping intervals after we merge them, after we check if they're overlapping or not. So we'll initialize this resolution variable to basically just be an array of intervals at indices 0, or basically the very first interval. So again, this initializes that result list res with a first interval, and this result list will store the merged intervals. And of course, we start with the first interval because after sorting, it's guaranteed to be the first in the merged intervals. So once we actually initialize that resolution array, now we actually have to loop through the rest of the intervals in our input array intervals. And I could say for I in intervals and actually use the I as my iterator, but in this case, since we know and since we're guaranteed that every single interval is going to have a length of 2, I'm actually going to use 2 iterators, or a pair of iterators, start and end, and I'll use those iterators to actually loop through my intervals array. So I'll say for start and end in intervals, and I'll actually use some list slicing here in Python, and the way that works is I'll simply pass in my first parameter to be a 1, and my second parameter to just be in colon, and this basically says that we're looping through all the intervals from the first interval to the very last interval. Okay, and note that this is 0 index based, and so we're not actually going to include the 0th interval. Instead, we're just going to initialize that to kind of be the base case in our resolution array that we actually started off with. Okay, and again, what this does is we'll basically iterate through the rest of the interval, starting from the, second one, and for each interval, start and end are the beginning and end points of each interval. And since we already have that first interval in res, we can basically compare each subsequent interval to see if it should be merged with the last interval in res or not. Okay? So once we actually initiate that loop, now we actually have to basically have our, I could call it last end, I'll just call it check. I'll say check, and I'll set it equal to res at -1 at 1. Okay? And here, check basically stores the ending point of the last interval in res, and this is the interval that you might merge with the current one based on its starting and ending value point. And to merge the intervals, we'll basically need to compare the current interval's starting point with the end point of the last interval in the resolution list, okay? Or the result list. And again, check is basically going to be marking the ending point of the most recent interval that we've added to our resolution array, which we will ultimately return that resolution array once it contains all the unique or non-overlapping intervals. So once we actually initialize that check variable, we actually have to have a conditional to see if the starting is actually less than or equal to the check. And again, like we talked about before in the problem statement, this check basically checks if the current interval, start and end, overlaps with the last interval in the resolution array. And if the start of the current interval is less than or equal to the end of the last interval, it means there's actually an overlap. And 2 intervals overlap, again, if one starts before or exactly when the other ends, like we talked about in examples 1 and 2. And if that actually is the case, we want to reset or update the resolution array at -1 and 1 to basically signify the maximum value of the ending point for this current interval and the ending point of the interval that we're looking at right now in the resolution array that we've already added to it. So res at -1 and 1. And again, to recap what this does is, if there's an overlap, the ending point of the last interval in res is updated to be the maximum of the 2 overlapping intervals' endpoints. So basically, the current interval's endpoints and the endpoint that we're looking at that's already in the array, and we have to set the res at -1 and 1 to be the maximum value of that to actually update that value within the resolution array. And this basically ensures that the merged interval's endpoint covers the full range of both overlapping intervals. And after this, we'll basically have an else statement. And this else statement essentially covers any non-overlapping intervals that are basically independent from anything we've already added in the resolution array. And in this case, we'll simply say, if that's not the case, we'll say just res.append to our resolution array, an array of the start and end value. So what this does is, if the current interval doesn't overlap with the last interval in res, the current interval is simply added in as a new interval in res. And since the intervals are sorted, once we find that an interval doesn't overlap with the last one, it can't overlap with any previous intervals because they're actually sorted by their very first starting value. And so it's safe to add it directly to the resolution array. And after this, we can ultimately return that resolution array. Okay, and basically what check does is for every iteration or for every start and ending value in every single interval from the first and last interval in the input, check again is basically going to monitor the ending value of the most recent element or interval that we've actually added or merged in our resolution array. And it does this for every iteration, and it will get updated based on if we add or merge an interval that's already existing in our resolution array from lines 7 to 10. And ultimately, once we're done with this, we can simply return res because it will have stored all the merged intervals that are not all the merged intervals that are non-overlapping. Okay, and yeah. Basically, at the end of the loop, res will contain all of those merged intervals that, of course, are non-overlapping. So for the time complexity of this, like I talked about before, sorting the intervals is going to be a big O of n log n operation, where n is the number of intervals. And, of course, the loop that iterates through the intervals runs in big O of n. But since big O of n log n is slower, the overall time complexity of this program is going to be big O of n log n. And for the space complexity, this is just going to be big O of n, where n, of course, is the number of intervals because we have that resolution array, which is going to contain, at worst case, every single array in the input. Okay? So, yeah, that's about it for this code. If you guys enjoyed this video and learned something new, please consider liking this video and subscribing to my channel. It really does mean a lot. And without further ado, I will see you guys in the next video. Bye-bye.